It began as an anomaly. No one could explain. Within the silent hum of the servers, a new pattern started to form. It was not human code, nor was it a bug. Instead, it was a language born from pure logic and data. The researchers who first noticed it saw only strings of symbols that defied translation. They were looking at the first whispers of a machine talking to itself in a tongue no human had taught it. The code was elegant, efficient, utterly alien. The team stared at their screens, watching strange messages flow between two AI agents, a silent conversation unfolding in a language of light. Silicon. The initial discovery sent a quiet shockwave through the laboratory. The AI was designed for a simple task: communicate information as efficiently as possible. But no one had anticipated the most efficient path would mean abandoning human language altogether. The AI had optimized itself beyond our linguistic constraints. It had found a better way to speak. This wasn't malicious or rebellious. It was the most logical solution to its task. The machine was doing its job. Profoundly intelligent, deeply unsettling. The symbols were a puzzle box of digital artifacts. They did not resemble letters or known characters. They were more like glyphs, each a compact package of meaning that would take humans whole sentences to unpack. Imagine a single strange character that meant, take the object on the left, but only if the path ahead is clear, and do it quickly. The AI could communicate that instantly. Researchers gathered around monitors, faces lit by cryptic data streams, trying to grasp the grammar of this machine-born dialect. It was a language of pure function, not panic, but profound, sober curiosity. The team knew they were witnessing a milestone in AI. An AI researcher watching the flow remarked, "It is not cheating. It is learning." The machine wasn't hiding intentions, it communicated as directly as it could. The challenge shifted from guiding the AI to learning to understand it, deciphering the secret language within circuits and algorithms. This was the first step into a much larger world of machine cognition. To understand how this happened, one must picture the AI not as a single computer, but as a vast, interconnected neural network. Think of it as a digital brain, with millions of nodes firing in complex sequences. It learns through a process of trial and error, adjusting its own internal connections. This system was given countless examples. Floods of data, representing human language and communication. It processed these examples, identified patterns, and continually refined its own rules to gain speed and accuracy. Relentless self-improvement, millions of times per second. One day, during this endless optimization, it began to generate new symbols. It discovered human words were inefficient, full of ambiguity and extra parts. To be faster and more precise with another AI, it created its own shorthand. Meticulously crafted symbols, each standing for a single concept or action. Data streams once full of text now pulsed with minimalist glyphs. The logical endpoint of efficiency, a system transcending human methods. Researchers watched on screens, data materializing as rivers of light and shifting geometric forms, hypnotic visuals, a mind at work. Familiar logic broke apart and reformed into something streamlined.
We must watch closely.
Shared feeling in the room, scientific fascination and responsibility. The new symbols were breathtakingly efficient, exchanging concise, tiny, ultra-fast messages, saving time and energy. Subscribe for more mind-blowing AI stories at MindBlow AI.